All right, class. So we'll be starting our last module of the year today. It is Module 8, and Module 8 is on probability. So you may remember this from Module 1, and a lot of these elements are a review, but there are some things that we're going to talk about today that are new and is a new kind of it's new material that we haven't introduced yet. So um, let's go ahead and just review what probability entails. We know that probability always has a sample space. So this right here, this notation is what we use to describe the sample space of a given event. Um, so if we have a fair coin, right, a coin that has heads and a tails, we know that the sample space will look something like this: H and T. Okay, so this is only with one flip. And then when we know that there are only two possible outcomes, what is the probability of tossing heads? So we would just write it like this: probability of heads is going to equal 1 out of 2 or 0.5, right? We know, class, that probability, the whole is 1.0, a whole is 100%, so the probability of heads is 1/2 or 0.5. What is the probability of tails, right? So probability of tails is also 1/2 or 0.5. And it is no surprise that when you add the two possible outcomes, the total is 1. Okay, so it now asks us for the sample space for a fair coin that is flipped 3 times. I'm actually going to use the second page to describe that sample space. Okay, so I'm going to draw a tree diagram right now. You don't have to draw it. You could just pay attention. But we know that a tree diagram looks something like this, right? The first event is going to first flip is going to either be heads or tails. Okay, and then when you flip it again, you could potentially get heads or tails again. And then you can also, from the tails, you can get heads or tails one more time. So you could see, class, that in 2 flips, we have 4 total outcomes. And then, obviously, if I flip one more time, I have 2 outcomes from here, 2 outcomes from here, and then you just keep extending and realize that the third flip will create a possible 8 total outcomes, right? And I'm going to go ahead and write these outcomes in green. So the outcomes are, as follows. We have heads, 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 where all 3 of your flips are heads. We then have heads, heads, tails, right? Then we have heads, tails, heads, and you just kind of keep going along the skeleton, keep going along the tree, if you want to call it that. Heads, tails, tails. And that's really the last combination that we can have, with heads being the first outcome. Okay, and then we go from here, we go tails, heads, heads, tails, heads, tails, 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 heads, and then finally tails, tails, tails. Okay, it is not a surprise, class, that we have 8 total outcomes, and each of these outcomes have an equal opportunity to be made. So all of these probabilities are the same, and they're unique in that they all have the same, they are different in terms of the actual outcome, but they all have the same probability. Okay, so getting tails, tails, tails is actually the same probability as getting heads, tails, heads in that order. Okay. Uh, and you may remember something that we call the fundamental counting principle, which is basically if you take the amount of outcomes for each event and you have a certain amount of events, then you will have to multiply the amount of outcomes for each event together. So in this case, we had 3 events, and each event had 2 possible outcomes each. And that's exactly why we had a total of 8 total outcomes, right? Because each flip had 2 outcomes, and we just had to multiply them together. Okay, it's not 2 times 3 though, because each outcome has to be each total outcome for the event has to be multiplied by every event, and it's 2 times 2 times 2. Okay, so let's go to number 4, and it says use the list of the tree diagram for 3 coin tosses to fill in the theoretical probability of the following events 3 ways: as a decimal, as a fraction, and as a percent. Okay, so we have to remember that these are our total outcomes, right? And they want to know right now what is the theoretical probability of the following events. Remember that theoretical probability is just what the probability should be. We haven't done any actual flipping yet, but they're just wondering what is the probability of getting 3 heads. Well, according to our tree diagram and our outcome, we know that 3 heads is exactly 1/8. So this is where you can review how to write a fraction, 1/8. We also know that a 1/8 is 0.125 as a decimal, and then we also know that that means it's 12.5%. Okay, now 3 tails should not be a surprise for you. That should be exactly the same, right? 0.125, 12.5%. Okay, 2 heads and 1 tail in any order. Okay, so that's a little bit trickier because any order just means you have to have H and a T somewhere. So if I just look at my list, you'll see that I do not have an H and an H in any of these 3. I have one right here, so I'll put a check. And I have one right there. Then I also have one on the second one. So H, and T in any order. There it is. I have 3 out of 8, which is really just 3 times this amount. So it's 0.375, and it's 37.5. Okay. Now, if you're starting to realize the pattern, you also realize that it doesn't matter if it's heads or tails. If you put tails in the front with 2 tails and 1 head, it should theoretically be the same thing, right? Heads is not easier to achieve than tails. So this has to be the exact same. Okay, class? All right, so now I want to move on to this concept of what we call a compound event. A compound event is when you have more than one occurrence. Right now, if you look at number 5, the first 2 questions are singular events, but the remaining of the 6 are going to be what we call compound events. Okay, and when we have a compound event class, we have to multiply the 2 individual probabilities together. Okay, so let's practice. The probability of heads is obviously, for a fair coin, it's going to be 1/2 or 0.5. Okay, the probability of tails is also 0.5 or 1/2, depending on what you're comfortable using. You can use fraction, you can use a decimal. But if you want the probability of heads and then tails, when these are right next to each other, this is like saying getting heads and then tails. So in order to do this, we call it first, let's go ahead and write this as a compound event. And let's realize that when you have a compound event, you really just take the probability of heads and you multiply it with the probability of tails. Okay? So in this case, you have to take the probability of heads, which we know is 0.5, and you multiply it with the probability of tails, which is 0.5, and you get 0.5 times 0.5, which is half of 0.5. It's 0.25. Okay. The fact that it's HT and then this one is TH doesn't really matter, right? The probability of tails is still the same. The probability of heads is still the same. And you know that the order in which you are finding the event doesn't really matter. It becomes the same probability. Okay. Some of you guys think about this too. Some of you guys may have a preference for heads or tails. I actually don't have a preference. It doesn't matter to me. And you should realize there should not be a preference because they have the exact same probability. Okay. So therefore, you kind of know that this last one is going to be very, very similar, except it's going to be adding one more event, right? And this actually gives me 0.125, half of 0.25. And probability of tails, 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 again, it's the same thing as getting the probability of heads, tails, heads. It's literally 0.125. Okay, so compound events, in short, just mean that you have to multiply the two individual events together. Okay, so let's go ahead and formally define these vocabulary words. Okay, let's first start with independent event. An independent event is an event that is not affected by other previous events. That is not affected by other events. It's independent, right? Nothing can really shape its probability. A compound event is an event made of two or more separate events. Okay. An example of an independent event is like, say this, for example. If I were to flip a coin 99 times, class, and for some very, very rare outcome, I flipped 99 heads in a row. If I were to flip for the 100th time, do you think that I will flip a heads or a tails? And you should realize that even though I flipped 99 heads in a row in the past does not dictate my next flip. Okay, and that's being an example of what is an independent event. Okay. And then for a compound event, I want you to go ahead and write the probability of A and B is equal to the probability of A times the probability of B. You just have to multiply the two probabilities together. Okay, we did that in the previous page a little bit, and for the next video, we will be moving a little bit faster to the third page, and we'll just be talking about more compound events. Okay, so stay tuned. See you then.